Hello and welcome to another Earth Science podcast. I'm your host, Mr. Buss, and this podcast will be talking about light, heat, and energy. Alright, so the sun is the source for most of the planet's energy. So energy leaves the sun and travels through the vacuum of space and comes to our planet. If we're talking about high energy, short wavelength, we're looking at gamma rays, then X-rays, ultraviolet and visible light. And as the wavelengths start spreading out and the energy is a little lower, you get through infrared and radio waves. So energy in a variety of forms is reaching our planet from the sun. Alright, so how do we harness the sun's energy for our use? Well, obviously we can use solar panels and directly convert sunlight energy to electrical energy. Wind energy is actually an indirect form of solar energy. The sunlight heats the Earth's surface, which then in turn heats the troposphere or the atmosphere, which causes our wind. And the wind is basically a form of solar power energy, just a little bit different. Okay, now fossil fuels are also storing the sunlight's energy. How could that be? Well, fossil fuels are decayed organisms, mostly plant material in nature, and so when plants, basically were buried, they were converted to a form of fuel over long periods of time. So when you burn coal, you're burning an ancient plant material, and that material got its energy originally from the sun. And hydroelectric, even though it's indirect, is also a form of energy that we can harness from the sun because the water cycle is powered by the sun as water evaporates and then rains down, and you can capture the hydroelectric power in rivers as well. A type of energy not given to us by the sun would be Earth's internal energy radiating outwards. So the Earth has been trying to cool since it formed, and that internal energy in the form of radiation is also a form of energy that is found on the planet. So to summarize, the sun is the source for most of the planet's energy and even fossil fuel energy. I already talked about coal, but gasoline, gasoline is refined from oil. Where did the oil come from? Well, oil, as opposed to coal, oil formed in the oceans, and it formed as plankton. So, small microscopic little creatures, as they died and settled to the bottoms of the oceans, they then became buried and became sediments and covered, and when they decomposed, their bodies got slowly converted to oil, which is now harnessed and used by people. But it all comes back to the sun. The sun had originally provided the energy that was harnessed by the plankton. So when you're burning gasoline in your car, you're really burning energy that was harnessed by plankton, microscopic creatures, millions of years ago. So where does the sun get its energy? Well, I'm not going to go into details here. That's beyond the scope of this course and this podcast. But the sun undergoes nuclear fusion, where it's basically taking hydrogen, protons, fusing them together, releasing energy in the process through a series of steps, and forming heavier elements like helium in this example. So I already mentioned the magnetic spectrum. The electromagnetic spectrum is simply looking at what types of energy are being released and correlating that to the wavelength, so gamma rays down to radio waves. So as we go through the rest of this podcast, it's important to understand a couple definitions. First of all, what is heat and what is temperature? Heat is defined in the textbook that we are looking at in class as energy associated with the movement of atoms or molecules that can be transferred, whereas temperature is a physical property of the matter that expresses how hot or cold it is. Well, that might or might not make sense. I think it's easier to look at just a real example. I have a picture of a coffee cup here, some hot coffee, and Lake Superior in the winter. Well, obviously Lake Superior is going to be colder, and the coffee is going to be warmer in terms of the temperature. So temperature for each, that's easy to understand. But what about heat? Which one contains greater heat? All right, well, that's confusing. But I'm going to have to go with Lake Superior. Lake Superior, even in the winter, is going to have a greater heat energy as opposed to the little coffee cup here. I think you have to understand that even though the water is cold, it could get a lot colder. It is way above absolute zero, or negative 273 degrees Celsius, right? So there is a ton of heat stored in Lake Superior, even in the winter, as opposed to a coffee cup, which has a greater temperature, but just much less volume in terms of how much water we're talking about. All right, so we have to understand the difference between convection and conduction. All right, so convection is basically the movement of heat. So when in this case, water is heated at the bottom here of the pan that's in the fire, the molecules are actually moving towards the top. So the movement of hot particles up and then cold particles down, that's convection. All right, conduction is what's happening on the handle here. The handle isn't moving, it's staying still, but the heat itself is moving along the handle. So conduction is movement of heat through an object that stays still, whereas convection is the movement of the object itself, transferring the heat from one area to another. So in my next two slides, we're going to kind of take a closer look at convection and take a look at some thermal convection, which is really going to help us understand a lot of processes that occur on Earth. All right, so in this example, we have a heat source at the bottom here. All right, so what have we seen so far? We've seen convection. We've seen the liquid here rising because it's gaining some heat, and the molecules are getting faster and moving around and spreading apart. And they're going to reach the top of the little chamber here, and those molecules are then going to peel off to either direction. So what you've got is a convection cell. You actually have two of them. As the molecules cool, they fall, and then they're going to return to the heat source and continually rise and fall into convection cells throughout this little chamber here. So this example is going to be very similar. You're going to have a heat source along the bottom here. It's going to be uniformly placed, so it's going to be interesting to see what develops as this goes. And this is going to be running at a faster speed, so it's a little bit of time lapse here. So it's interesting to see you actually get a very similar pattern of heat dispersion, even though it's uniformly heated at the bottom. You still get convection where the heat's moving up and then it's deflecting off to either side, and then as it comes down it cools and returns kind of in a similar pattern. So you're actually getting two convection cells going on here, and I think it's crazy, and it's neat to be able to see that. All right, so where does this happen? Well, this happens on the surface of the Earth in the troposphere. This happens as well in the mantle and in the inner core of the Earth, where we have convection going on. So here's kind of an example of what I'm talking about. Here's the inner core, which is solid, so you're not going to have convection going on in the inner core. But in the outer core of the Earth, which is metal as well, you have convection cells going on here. And again, we talked about in class how that's one of the reasons, or the reason, why we have magnetic field, because the metal, the liquid metal, is actually going through motions here and causing our magnetic field. And you have convection as well in the mantle, or the hot rock of the Earth that is under the crust. As convection goes on here, you get rifting of the Atlantic right here, shown here, as the hot rock goes up and then scrapes across the crust, and you have rift going on. You can see subduction here as well, in areas where the crust is subducting under and cooling off and then rewarming and then going back into these convection cells. So convection is happening inside the Earth, and it happens in the atmosphere as well. So, you know, the sun heats the surface of the earth, which then warms the air, and the air rises, and then it cools and it falls. And the surface of the earth warms the air and it rises, and then it cools and it falls. And that's why we have weather. And that concludes this podcast on light, heat, and energy.